Hey guys, and welcome to yet another Java tutorial. In this tutorial I will show you how to encrypt and decrypt files using DES algorithm. So the DES algorithm stands for Data Encryption Standard, and it is a symmetric key algorithm for the encryption of electronic data. That means that we will be using same key for both encryption and decryption of data. DES is the block cipher, an algorithm that takes a fixed length string of plain text bits and transforms it through a series of complicated operations into another ciphertext bit string of the same length. In the case of DES, the block size is 64 bits, and DES also uses a key to customize the transformation so that decryption can supposedly only be performed by those who know the particular key used to encrypt. The key ostensibly consists of 64 bits, however only 56 of these are actually used by the algorithm. 8 bits are used solely for checking parity and are therefore discarded. Hence the effective key length is 56 bits. The key is nominally stored or transmitted as 8 bytes, each with odd parity. So that's a bit of theory about this algorithm. Now let's create our Java project. So file, new Java project, and let's call it cryptography. Okay. Now let's create new package, and let's call this package DES. Finish. Now let's create a new class, and let's call it also DES with capital letters. Okay. So first we need to import few things. So these are the imports that are required for this class. So you can pause the video and type all these imports if you are watching and doing the same things as I do. Now we need to create a method that will do both encryption and decryption. So it will be public static void, and let's call it encrypt decrypt. Okay. Now the parameters of this method will be a string that is a key. The second parameter will be a cipher mode, so that this method will know if it should encrypt or decrypt data. So int cipher mode. The third parameter will be input file, so it will be a file that we want to encrypt, or it will be a file that we want to decrypt. And the fourth and the last parameter will be output file, so this file will have the contents of encrypted or decrypted file. This method will throw a few exceptions. So first exception is invalid key exception, then no such algorithm exception. Next is invalid key spec exception, no such padding exception. The next one is IO exception, and that's about it for now. Okay. Now first of all we need to create a file input stream from our input file. So file input stream FIS, it is a new file input stream, and the parameter is our input file. Next one is file output stream FOS, and it will be a new file output stream and the parameter will be our output file. Okay, now we need to create a des key spec object. So des key spec is a new des key spec, and we need to pass the bytes of our key. So remember that this key has to have 8 bytes minimum. So we need to convert this string to a byte array. So key dot get bytes. Okay. Now we need to create a secret key factory. So secret key factory skf new or secret key factory get instance, and the algorithm will be a des algorithm. Okay, now we need a secret key. So this will be a secret key, and we will create it using generate method from secret key factory object. So skf dot generate secret, and we need to pass the des key spec as a parameter. Okay, now we need to get Cipher. So Cipher is Cipher dot get instance, and instance will be des algorithm, and the Cipher mode we'll be using for now ECB, that stands for electronic codebook, and the padding will be PKCS5 padding. Okay, so now we need to have an if statement. So we need to check if we are using this method for encryption or decryption. So if Cipher mode is equal to Cipher dot encrypt mode. In this case we want to encrypt, of course, our file. So we will initialize our Cipher object. So Cipher dot init, and we will say Cipher dot encrypt mode, and the second parameter will be secret key, and the third parameter will be a source of randomness. So in this case we can say secure random dot get instance, and instance of SHA1 PRNG. So SHA1 is a hash algorithm, and PRNG stands for pseudo random number generator. So this is our source of randomness. Now we need to create a Cipher input stream. So Cipher input stream CIS is new Cipher input stream, and the first parameter will be our file input stream, and the second parameter is a Cipher. So Cipher. Okay, now if we want to decrypt, so else Cipher mode is equal to Cipher dot decrypt. In this case we just can copy this. Here we have a typo else if, and instead of encrypt we should have decrypt mode, and instead of Cipher input stream we need a Cipher output stream COS new Cipher output stream, and as a parameter we will pass file output stream and Cipher. Okay. Now we need to write to a new file, to output file. So let's create a new method for that. It will be private void static void, and let's call it write, and the parameters will be input stream and output stream. Okay, now we want to have a buffer, so let's create a buffer. So byte array buffer is new byte array, and let's say we want a byte array of 64 bytes, so you can type any number you like. Now we need to have a variable to store the number of bytes read from the input file, so integer number of bytes read. We declare it like this. Now we want to read a file, input file, and to write the bytes that are read to the output file. So we need a while loop, so while. Now in this while loop we need to read files, input file, so, and we need to know how many how many bytes have we read in each iteration of this while loop. So number of bytes read is input stream dot read and we want to fill the buffer with the bytes that we read from the input stream. So as a parameter we'll write buffer, and we need to know when we reach the end of a file. So if we reach end of a file, the read method will return -1, so we need to make sure that it is not -1. Okay, now we need to have throw IO exception. Okay, now inside our while loop we need to write the bytes to our output stream. So out.write, so we want to write bytes from the buffer. The offset is 0 and the number of bytes is placed in this number of bytes read integer variable. Okay, and at the end we want to close our output stream, so close, and we need to close our input stream, close. Okay, so these are the methods for encryption and decryption. So let's write a main method. So public static void main string array args, and I actually have a file here, so this is this file, so this is some random text in this file, as you can see, and we want to encrypt and decrypt this file. So first let's encrypt it. So we need to create a file instance, so file plain text is a new file, and now we need a location of this file as a string, So let's go to properties of this file, and this is the location. Let's copy this and paste it here, and we need to add / plain.txt, the name of the file. Okay, now we need to create instance of encrypted file. It will be a new file. Let's use the same location, but instead of plain.txt, let's write encrypted.txt. Okay, and now we need to call the encrypt decrypt method. So encrypt decrypt. Now the key needs to have the 8 bytes, so at least we need 8 characters. So let's write 1 2 3 4 5 6 7 8. The cipher mode will be encrypt mode, and this will be a plain text file, and this will be encrypted file. Okay, and now we need to surround this with multi-catch, try and multi-catch. Okay, and after this is done, we want to write something like systemout.println, and let's write encryption complete. Okay, now let's run this. Actually, we need this write method we need to place under the Cipher input stream. So we want to write our Cipher input stream and file output stream. Okay, and if the decrypt mode is, we need to call the write method as well, but this time it will be file input stream and Cipher output stream. Okay, now we can run this. So we have message encryption complete, and now we have a file encrypted, and if we open this file, we'll see the encrypted text. So these are some symbols that are representing the encrypted bytes of this file. Now let's say we want to decrypt this, so we want to turn this into this text. So instead of plain text, we want to use we will have this encrypted, and we will have a new file that is called decrypted. And now we will place encrypted here and decrypted here, and instead of encrypt mode, we will have a decrypt mode, and the message will be decryption complete. Okay, now let's run it. Now we have the message decryption complete. There is the decrypted file. Let's open it, and this we have our decrypted file. Okay, so now I want to show you one more example of this DES encryption, but instead of electronic codebook mode, we will be using CBC. Now, when we are using blockchaining, we need extra parameter in this initialize function. So we need IV, that is initial vector. So now we need to have initial vector, and it will be a byte array of 8 bytes. So IV bytes It is a new byte array of 8 bytes, and now we need to fill this byte array with the random bytes. So we'll need to have IV parameter spec object. So IV, it is a new IV parameter spec, and as a parameter of this constructor we will pass the IV bytes. Okay, now this IV we need to place between the secret key and the secure random, so here. Okay, and we need to add one more throw declaration, so invalid algorithm parameter exception. And this IV we need also to place here in the decrypt mode. So when using CBC you need IV parameter spec object, and you can place it here as one more parameter in this initialize method. Now let's add one more catch, so add catch clause to surrounding try. Okay, now let's have our plain text, so plain, and let's create encrypt mode. This will be plain and this will be encrypted. Okay, now we can delete these, and now let's run it. Encryption complete. We have our encrypted file. Now instead of encrypt mode we will have decrypt mode. We will decrypt encrypted file, and it will write this decrypted data to our decrypted file, and we will change this message to decryption complete. We have this message decryption complete, we have decrypted file, and there's our text. So that's it, guys. This is all for this tutorial. I hope you liked it. Vote up, subscribe, and I'll see you in the next tutorial, and bye for now.